Using reasoning with representations to divide decimals. Let's begin by close reading our problem. Lucinda made 50 8/10 liters of punch for a celebration. She stored an equal amount in 4 different coolers. How much punch was stored in each cooler? Model by representing with an equation. Show 2 other ways to represent this problem. For example, you could use base 10 blocks, money, number lines, or grids. Take a moment to retell this situation to a partner. What do we know? What are we trying to find out? What might the equation look like? How could we use math tools to help us solve this problem? Lucinda has 50 8/10 liters of punch. She is putting an equal amount in 4 coolers. We are asked to model with an equation and to show 2 other ways to solve this problem. If we model this equation with an unknown, we need to use a letter to stand for the unknown part. Let's use N as the number of liters of punch in each cooler. If we have 50 8/10 and we're separating it into 4 equal coolers, then this is a division problem. 50 8/10 divided by 4 equals N. This video shows 2 different ways to solve this problem. This problem is a little different from the previous ones we've solved. It involves a large number of whole liters. It would take a long time to represent all of the wholes for this problem. This lesson discusses ways to reason about dividing decimals without drawing all of the wholes, but keep in mind that you may draw some. In Lesson 3, we explored some reasoning shortcuts with a number line. Today, we will think about how to use decimal grids and money with reasoning to solve this problem. Representing with grids. If one decimal grid represents 1 liter, we could shade 50 8/10 on the decimal grids and separate that into 4 equal coolers, but that would take a long time. So let's begin using some information we know. Let's build 4 boxes to represent each cooler. Now we know we have 50 and a little more. How many full liters could go in each cooler? Since there are 4 coolers and I know 4 times 12 equals 48, I know we can at least put a full 12 liters into each cooler. Let's do that first. If we put 48 whole liters in coolers, then we have 2 8/10 liters left to share between the coolers, since 50 8/10 minus 48 is 2 8/10. Now we can use decimal grids to share the remaining punch between coolers. Since it is more than 2 but less than 3 liters left, I will use 3 grids and shade the amount that I have left to share. Since there are 4 coolers, I can give each cooler a ½ liter using the 2 full liters that are left. Now we have used 2 of the 2/8 liters, so we have 8/10 liter left. 8/10 shared equally by 4 coolers is 2/10 each. Now all of the punch has been shared equally between the 4 coolers. We find the total for each cooler by adding the 12 liters, the 5/10 liters, and the 2/10 liters. The total is 12 7/10 liters of punch. So 50 8/10 divided by 4 equals 12 7/10. Another way that we can solve this problem is to think about money. Money can be helpful when thinking about decimal problems even when the problem doesn't involve money. In this problem, we are sharing 50 8/10 liters of punch with 4 coolers. What you must be careful to remember in this problem is that the decimal is 8/10 and not 8/100. 8/10 of a dollar is 80 cents. So this is like sharing $50.80 into 4 groups. To help us remember the real context, we can pretend we're putting the money in coolers. Just like the grids, we can think about what the largest whole dollar amount is that will go in each cooler. Since 4 times $12 is $48, we can put $12 into each cooler. Now we have shared $48 of the $50.80. $50.80 minus $48 is $2.80 still left to share. We can exchange the dollars for 4 quarters so that they can be shared. Now we can give 2 quarters to each cooler. Now we have 2 quarters and 3 dimes left, or 80 cents to share. Let's exchange the 2 quarters for 5 dimes. Now that we have 8 dimes, each cooler can receive 2 dimes. Thank you for watching using reasoning with representations to divide decimals.